Hello, testing, testing. Is my mic working? Okay, cool. Hello, good morning, or evening, or afternoon, wherever you are. We are doing more Google interview questions today. We've been going down this list, huh? By the way, this is my brother's Leetcode premium account, not my own. So just because it says it's done, doesn't mean it's done, and vice versa. I think the topmost problem we haven't done yet is adjacent increasing subarrays detection 1, which is allegedly an easy question. 3349. Okay, here we go. Leetcode 3349. Bam. Okay. Adjacent increasing subarrays detection 1. Given an array nums of n integers and an integer k, okay, determine whether there exist two adjacent subarrays of length k such that both subarrays are strictly increasing. Specifically, check if there are two subarrays starting at indices a and b where a is less than b. Do they have to be like directly adjacent? Both subarrays a to a plus k minus 1 to b plus k minus 1 are strictly increasing. The subarrays are adjacent, meaning b is equal to a plus k. So a all the way to k minus 1. Got you. So b starts at a plus k. Okay. Return true if it is possible to find two such subarrays. False otherwise. Okay. Output is true. The subarray index starting at index 2. Gabriel says, hey Gabriel, how are you doing today? The subarray starting at index 2, 0, 1, 2 is 7, 8, 9, which is strictly increasing. The subarray starting at 5, 0, 1, 2, 3, 4, 5, 2, 3, 4, got you, is also strictly increasing. These two subarrays are adjacent, so the result is true. Okay. Does that mean I can also have something like this? Just like a subarray that's just increasing all the time? Like 2, 5, 7, 8, 9, 10. And then my k is equal to 3. Would this part and this part be my answer then? K equals 5. 1, 2, 3, 4. Oh, they have to be strictly increasing, right? So they can't be equal to another. Okay, I see. How do we do this? I mean, from like a human standpoint, how do we do this? K is 3, right? So we would probably, intuitively, we would scan through the entire array, right? Like 2, 5, 7, 8. Okay, these are increasing subarrays. All right. Hmm. 2, 5, 7. Is this like a sort of a sliding window problem? So anytime we get to a subarray of length k, we're like, okay, check, and then we move to here, maybe? Wait, no, but then the answer is over here. 5, 7, 8. What's the input constraint? constraint is nums.length is less than 100. So it sounds like we could do a more brute force scanning method. Nums.length. Store the longest decreasing subarray starting and ending at an index. Decreasing. It's small input, so brute force will work. Okay. Why is the hint telling us to do this though? Store the longest decreasing subarray starting and ending at an index. Store the longest decreasing. Does it mean increasing? Subarray starting and ending at an index. Decreasing. Starting and ending. What? Starting and ending at an index. Okay. Okay, let's go with increasing first. So 2578. 25789. So I'll be like, okay, there's a subarray length of 5 over here. And then 4, 3, 2, and then 1. Over here, we have an increasing subarray starting at 2. 1, 2, 3, 3, 2, 1, 1, and then 1. Hmm. 3D by Leo says, I've been waiting for you to stream on Twitch, and it turns out you're on YouTube, lol. Oh, hey 3D by Leo. How you doing? I should be streaming to Twitch right now. I dual stream. Hey 3D by Leo, how you doing? My brain is dying on this easy coding problem. Check if there are two subarrays starting at indices A and B, A less than B where? Why does this feel kind of hard? I mean, what's the brute force way? Is the hint suggesting so that we can subtract not compliant decreasing subarrays and see if we have enough numbers to add up for the k subarray? Store the longest decreasing subarray starting and ending at an index. So we can subtract not compliant subarrays and see if we have enough numbers to add up for the k subarray. Oh, I'm not sure. What happens if we try to do that? Store the longest decreasing subarray starting and ending at an index. Okay, so where is it decreasing? 2, 5, 7, 8, 9, 2. Okay, so it's here. Starting here will be 9, 2, 3, 4, be 2 over here, 3, and then 2, and then 1. And then everything else should be 1. How is this an easy question? Okay, so what can we do about this info? The answer is 7, 8, 9, and then 2, 3, 4, right? The 2 is right over here. Oh. Hold up. the answer is just a peak over here in decreasing arrays. 2, 7, 8, 9. There's only one peak here. Huh. Wait, I don't get it. What if the brute force is just 2 loops, and when you find enough elements strictly increasing, increase your counter, then if k, a counter is equal to k, return true. You know what? Yeah. Am I just overthinking this? I feel like you can indeed just have a, like, you can have like a int 2 adjacent subarrays, like subarrays found is equal to 0, and then int count is equal to 0. Okay, and then you iterate from start to end in the array. Yeah, every time you get an increasing element from the previous one, you increase your count. Once your count is equal to k, you reset it, subarrays found, ++, and then when subarrays found is equal to 2, you return true. Okay, but we have to make sure that it's like, it's adjacent. So how do we watch out for that? I guess every time you reset your count, wait, if you reset your count, like what happens if you find out that the second subarray you're counting is like not a complete increasing subarray? How do we detect that? So if your subarray found is already 1 and your count is if your count is going, I guess, does count matter? Wait, I'm kind of confused. Hold up. Okay, this is the really easy case, right? 1, 2, 3, 4, 5, 6. You go through here. Your count is now 3, so reset everything. Reset count. Subarrays found is now 1. You go through here. Count will equal to k eventually. Subarrays found is equal to 2. Return true. Okay, that's fine. That's good. That's the happy case. What if you have like a 1 over here? What happens? Everything is 0 at first, right? So you go through 1, 2, 3, count equals 3. That's cool, and all subarrays found is 1. Four, 5, 1. So up to 4, 5, the count is 2. And you see 1, you're like, oh man, we need to start over now. So this gets reset to 0. Subarrays found is 0. Okay, what about the example here? Mm-hmm. 3D by Leo says, okay, you gotta confirm if I'm crazy or not, Chet. Is this a rebrand from a certain spaceman? What are you talking about? What spaceman? Yeah, it is. This is a alt account. Yeah, I made this account just for grinding Leetcode because I'm job hunting right now. I don't want to contaminate my old account with Leetcoding. That's basically it. 25789, 23431. Man, I'm actually kind of stumped here. Why is this an easy question? 257, 25789. So there's 5 things over here. Dario says, hi, Chet. Hi, how you doing? Count is going to be 4 all the way here. Rudy by Leo says, well, okay. You look and sound the same. Is my voice actually that distinct? I feel like it sounds like a lot of other people's voices. I'm glad I have recognizability though. 3D by Leo says, what is this, by the way? I want to do some coding practice too. Oh, this is a site. This is a site called Leetcode. Oh, I realize it doesn't say Leetcode anywhere. Leetcode.com. Yeah, Leetcode. I have a very specific way of speaking. Dang, really. Yeah, this is called Leetcode.com. It contains a lot of coding interview questions that you can practice. A lot of these are actually, actual real interview questions from fan companies like Google, Microsoft, Facebook, etc. So if you know how to do a lot of these, you have a better chance of landing jobs at, tech companies. Your voice reminds me of Saikuno, and he went kind of viral because of his voice. Wait, that's actually not the first time. That's actually not the first time people say I sound like Saikuno. Dang, really? Hold on. Like, I don't think we sound that much alike. Maybe like we're in the same realm of calm, maybe. Gonna just do like Saikuno talk.
When's the last time you've been? You don't have to answer this, by the way. When's the last?
When's the last time? You don't have to answer this, by the way, but when's the last time? Nah, I don't think. Yeah, it's probably just the calm tone. You know what? I'm actually like stupidly stumped on this question. Is it actually time to look up the answers for an easy question? Because there's like 5 increasing elements here. How do I even handle that? Count is equal to 5. And then, okay, so when we get to 2, we set this to 1. And 2, 3, 4. Count is 3. Okay. Okay. Why do I get a feeling, but... Okay, I'm gonna make one measly attempt at solving this, and if it doesn't work, I'm probably gonna take a look at the solutions. Okay, here we go. I'm gonna try to maintain some sort of these 2 variables, basically. Yeah. Okay. This sounds like sliding window problem. Is it sliding window? Wait, maybe it is. 25789. Okay. Subarrays found is 9. I mean 5. And then after we get to here, but every time you find a number lower, you have to start your window again. So left is equal to 0, and right is equal to, sure, 0 at first. You expand over here, 2, 5, 7, 8, 9 to 5. So right is now 4. 0, 1, 2, 3, 4. And you're like, okay, I have subrace found is 1. And then you reset your window starting here at 2. So it's now 5. So now you're like, okay, if this is now equal to 3, then I'm good. 2, 3, 4. It is, so. Okay. I have a very hazy idea of what to do now. Okay, thanks for the hint, Dario. It's still not completely, like, fleshed out in my head, but I think I have some idea what to do. Okay, so let's start the left and right at 0. While, what do we do? While the right is less than nums dot length minus 1. So as long as the right is not out of bounds, we should be good. Or just nums dot length. Okay. Okay, what do we do? If the next number is in bounds and it's greater than me, then I expand the right. Okay. If right plus 1 is less than nums dot length and nums right plus 1 is greater than the previous number, nums right. Okay, so if the next number is in bounds and the next number is greater than me, then you write plus plus. Okay, and if the right, if the subarray becomes length 3, you increase your subarrays found by 1. If right minus left is equal to 3, then subarrays found plus plus. Okay. 0, 1, 2. 2 minus 0 is 2, okay. Minus k. So if we're 0 here, and we're at 1, 2, that's 3. 2 minus 0 is 2, okay. Sure, so we're looking for 1 less than k. Subarrays found, plus plus, okay. Else, okay. What if the next number on the right is less than us? So else if right plus 1, I could probably combine a lot of these statements. Okay, I'll worry about combining all these similar statements in the future. Right plus 1 is less than nums dot length. So once again, if right plus 1, if the next number is less than, well, if the next number is in bounds and nums right plus 1 happens to be less than or equal to nums right. So if the next number is in bounds and the next number is less than or equal to the current right, what do you do here? You reset. Well, you reset only on certain conditions, right? So if the previous subarray was length greater than 3, then you keep the count. If it's less than 3, then you start over. Okay, that makes sense. So how do we know that the previous subarray found is? So if the right minus the left minus 1 is less than or equal to k. Krishna says, I think you are complicating this more than you have to. Wait, really? How am I overcomplicating this? Is it because the conditionals? Yeah, I realize some of the conditionals are repeating, but I can probably simplify it in the future. Right minus left. So if the current right minus the left minus 1 is less than or equal to k, is less than k, okay. Meaning the previous subarray, not length k, then we reset these subarrays found. Subarrays found is equal to 0, and then either way, we set the left is equal to right plus 1. I think this should be medium problem. Thank you for the sympathy, man. Then right is equal to right plus 1. Okay. This is my plan so far. Pretty sure it doesn't work, but let's do some sanity checks and see what goes on. Okay. Can't we just keep a dp of the largest length of increasing subarray at I and use it to find the answer? Oh shoot. He might be right. So we keep a dp of the length of the largest increasing subarray at I and use it to find the answer? Yeah, okay. Wait, hold on. Let me do a quick check if this method works though. Return plus plus if subarrays found is greater than or equal to 2, then you return true, else you return false. Okay, let's see how badly we did here. But first, let me sign in. You need to find k in adjacent numbers followed by k adjacent numbers. Okay, let's see how badly we did here. While right is less than nums.length, oh, that's size. Oh, these are all lists, so instead of brackets dot get, no, nums dot get. Likewise over here, it's nums dot get, nums dot get. What's going on here? Oh, parentheses is needed. Namdakyat. Illegal start of expression. Oh no, why? A semicolon is expected somewhere? Oh. Please, work. Nums dot size. Nums dot size. Time limit exceeded. Oh no. Why? Oh no. Why though? System out println. What's the current? Let's print the left and right. Left plus space plus right. Hey Leo, do you code too? Oh look, we are doing something. So we're at 99999. Less than nums.size. What is nums.size? Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we're always just at the rightmost. Okay. Leo says, I code a little, but I'm not great at it, but I have an okay understanding, I think, lol. Oh, really? Very cool. Should I do this? If the next number is less than nums.size, then we write plus plus. And then we can simplify all these conditions too. Right minus 1. Okay, so we're increasing our right every single loop now, so we probably have a stop condition now. Nums.get right. Nums.get right minus 1. I can make games? Oh, very cool. What game engines do you use? Yushar says, do you practice every day? Yeah, I do. I know you can't tell right now, but I do. This question, man. 0, 1, 2. Dang. My brain, it hurts. Oh, you work in Unity. Very cool. 0, 1, 2. 2 minus 0 is 2. Okay, this should be good. Left is equal to right, and right is equal to right. Okay. Okay, we getting somewhere. I used to do a lot of action script lol. Action script. What is action script? Okay, we're doing something, boys. 0, 1, so we go up to 0, 5. 0, 1, 2, 3, 4, 5. And then we go 5, 6, 5, 7, 5, 8. Okay, we're doing something. It was during the Flash days. What? Dang. Made a lot of games when I was in high school. Oh. Very cool. So ActionScript is used to make Flash games? Huh. Okay, we're getting somewhere. For some reason, it's not detecting that subarrays found is greater than or equal to 2. Either we're not getting it to 2, or it's not getting into this if statement at all. So let me put some print statements here and hopefully we can debug. Found subarray length k. Okay. Why not N2 with 2 loops checking strictly increasing? Outer loop goes k steps. Zero, 1, 2, 0, 1, 2, 3, 4. It only finds subarray k over here. 0, 1, 2, 3, 4. Why does it only find the subarray here? Oh no. Okay, I think we found our problem now. It's detecting the subarray too slowly. Why is it doing that? If get right Four. I mean, yeah, 4 minus 0 minus 1 is equal to k. Wait, 2 minus 0. Am I dumb? 2 minus 0 will be our target. That would fit k equals to 3. Oh wait, plus 1. Oh my god, it worked. I was counting the lengths of the thing. I was counting the lengths of the subarrays wrong. God damn it. No. K is equal to 1. Zero, 1, expected true. No. Okay, we have some edge cases now. Some decreasing ones. Okay. Ooh. Okay, this is an interesting case. So it's basically just this one and this one, right? My code definitely does not account for this. So we probably should not pre-increment it. We should increment it at the end, yeah. Write plus plus at the end. Okay, we completely skip over the parts where yeah, we pre-increment so we never check the subarray's length 1. This should work, right? Please. Runtime error. Index. Okay, so now we have to start checking again if the index are in bounds. So if wait, shouldn't it do it here though? What? -1 out of bounds for length 10. Why am I getting negative indices? Oh, because right -1. Oh no. If nums if right is equal to 0 or okay. Dario says, hey chat, if k equals 1, the answer is always true, right? Oh shoot. Am I overcomplicating this again? I see what you're saying. Let me repaste my answer in. Okay. We got this. I feel it. I think we are close. Let's make sure it passes the few test cases first. Okay, cool. So if k is equal to 1 and nums.size is greater than or equal to 2, then you return true. Run. Can you put Gabray's test case and see if your current code works? No. Dang it. Wait, it literally just did it. Found subarray length k. Found subarray length k. Oh, wait. Can you put Gabray's test case and see if your current code works? I see. Yeah, our code definitely doesn't work if everything is decreasing, isn't it? Dang it. Okay, so my code definitely does not count for that. I am stumped. It's time to look at solutions. Holy crap. Okay. Man, how is this an easy question? Well, Sasuga Google interview question. There is no editorial for this. But this is increasing, right? Wait. 5, 8, and then -2, -1. Oh, this is all increasing. Hold on, I'm confused once again. Expected true 5, 8, -2, -1. There's 5, 8 subarray and -2, -1 subarray. Oh yeah, I see that. Output is false. Wait, why am I getting false? Let's use this test case. I literally find 2 subarrays length k. Do I reset it somewhere? Previous subarray not length k. System.out.println. Resetting count. Okay, we're resetting the count somewhere here. That's our issue. Whew. Okay. How is this an easy question? Let's also print out what our current subarray count is, plus subarrays found. Yeah, okay. We're definitely resetting the count somewhere. I have no idea why though. We're very close, boys. I can feel it. Okay, so 0, 1. Okay, that's line 2. It decreases from here, so we go 0, 2. Wait, this is increased. Do you really need a count if the subarrays have to be adjacent? I think so. Like, you want to track if the previous subarray adjacent to you is increasing, right? Wait, this is kind of weird. So we go from 0, 1, 2. And then we go straight to 2, 3. Okay, first of all, why are we decreasing the count over here? So if nums so we go to 0, 2. 0, 1, 2. And we're like, okay, we're resetting the count. How did I get here? Nums.getRight is less than nums.getRight minus 1. Okay, that's true. The next number is less. If right minus left minus 1 is less than k, oh, frick. Is this really the +1 thing now? Zani says, hello. Hello. Oh, why is this so pain? This one is expected true, but we got false. Okay, why? So 2, this is increasing. This is increasing. Is this not the same? This is really similar to what we just did. Use test case. So we got to 0 and 1. Yes, we found. Okay. And then we go 0, 2. And we, for some reason, oh. Because this is still increasing. Oh no, the increasing subarrays overlap. They overlap. How do we account for overlapping subarrays? Krishna says, I can provide you with a working DP solution. Huh. At this point, I might actually need it. There should be other cases where we increase the subarrays, right? You need to cut the subarray once you get to k length. That's not always true, right? For example, 2, 5, 7, 8, 9. How do you know when to cut this one of 3? Oh, also. Wait, hold on. If right minus left plus 1, can we just divide this by 2? Okay, modulo 2. Wait, divide by k, divide by k. Divide by k is equal to 2. Then you return true. This is so dumb. 0, 1, 2, 3. Divide by k is equal to 2, return true. Wait. Is this how you do? How do you tell if something is divisible by something? Okay, let's run. No. 4 is divisible by 2, is it not? I don't think I can send code via chat, sorry. Oh, that's fine. I appreciate you trying to help out. Wait, why does it not work here? 3 divide by k is equal to 2. What? Okay, 3 minus 0 plus 1 is 4. Divide by k, which is 2, should be equal to 2. Why is it not going here? System out that printed on. Is this not what I... Huh? Oh man, the struggles. What? Okay, so apparently we don't check it every time. Oh. We have to put outside. So this is, okay. Okay. I swear this works. This is gonna be so dumb. Oh man. Output is true, expected false. K is equal to 2. Okay, why? We're really close, by the way. 1411 to 1422. Sonia says, random question, why do you code in Java? Oh, it's just a language that I'm more familiar with. I know it's really hard to believe now looking at me, but it's really the language I'm more familiar with. It's the language I used at my previous job too, so I have a lot of experience coding with it. What is our answer? Expected false. 6, 13, 17, negative 20, and then 2. Oh, okay. It's not adjacent. Ooh, it's not adjacent. 6, 13. Okay. So 0 to 1. That's definitely a subarray. And then we go 0 to 2, which is just nothing. Why did we not reset the count? Subarrays found is equal to 0. Uh-oh, why are we not resetting the count? Right is less than or equal to right minus 1. Okay, so we should be entering here. Oh, because the previous subarray is not equal. Okay. So we go 0, 2, and then we go 2, 3, which is decreasing. Two, 3. This is still decreasing. Let's use this test case. Okay, there's something to it. The 17 and negative 20. Previous subarray not length k. Nums.getRight less than or equal to nums.getRight minus 1. Okay, that's definitely this case. Negative 20 to 17 is definitely... Okay. Okay, how do we get it to reset over here? Because the reason this is going to here is because negative 17 to negative 20 is definitely 2 in length, so it does not go here. Ooh. Do we not add a plus 1 here? Because we don't count this as 2. We shouldn't count this as 2 really, right? Because it's just decreasing on the way. If anything, it should be 1. Oh, my brain hurts. It worked, guys. It worked. There has to be a better way of doing this. There has to be a better way. This is way too complicated. I do not accept this as my solution. It finally worked. I want to try dynamic programming solution. I will not accept this as my last solution. Okay. How do we do this with dynamic programming? Krishna was saying, actually, we can totally take a look at the solutions now. I think we deserve it at this point. With dry run table. What is dry run table? Wow. This is really simple. Dario says, I guess what could have made it easier is to keep your window of size k. Keep your window of size k by adding to the left. Oh. Maybe. Wait, that still would not take care of the size. Would that take care of the case where it's just increasing, like 1, 2, 3, 4, 5, 6? So we would get 1, 2, 3, then 2, 3, 4, then 3, 4, 5. Ooh, that's kind of complicated. I don't know what to do with that. Okay. Yes, it would take care of that one, really? Huh, okay. Well, the sliding window days of this problem are behind us now. I wanna look at some actual elegant solutions. Define a helper function is strictly increasing to check if a subarray of length k is strictly increasing. Okay. Loop through the array up to, for each possible starting point, check if both the subarrays starting at 1 and the one at I plus k are strictly increasing. If both conditions are met, return true. If no such pair is found. Oh, so that's how they're brute forcing this. I see. So for literally every single index, they do a helper function to determine if a subarray is increasing. So for every index, they check subarrays I through k and I plus kk. Oh, for every index, they literally check the next two subarrays with k length emerging from it. Okay, I see. And apparently this works because it's fine to brute force like this because that one is n squared, right? Yeah, that should be n squared. Mine is... What is mine? Mine is n time, right? Okay. Python 3 6 lines. Okay, this is Java. Mono. That solution won't work for medium version where the input constraint increases. There's follow-up question number 2. Oh, there is? That's fantastic. People were talking about a dynamic programming solution, right? Dynamic programming here. Okay. Store the length of the previous increasing subarray. Oh, this is what Krishna was doing. It starts at 0. Okay. Iterating through the list, starting from the second element. This is because we're comparing each number to its preceding number. Okay. Second, okay. Cool. Checking for increasing subarrays. Checks if the current number nums I is greater than the previous number. If it is, it means we're continuing on increasing subarrays, so current increase is incremented by 1. Okay. This is a lot of reading. This is really... Wow. Always fun to see Lee's solution, lol. Yeah. Previous increase is equal to 0, current increase is 1. Longest k is 0, okay. start I at 1, while I is less than, while I is inbounds, nums.get I. Okay, so if the current number is greater than the previous number, current increase plus equals 1, else previous increase is equal to current increase. Wait, this is sliding window. Why is it so simple when they do it? Longest k is equal to math.max, the current longest k, math.max current increase divided by 2. Oh my goodness, what are they doing here? There's two max statements and 2 min statements. Yeah, my brain hurts too. Really? I feel like they optimize that too much. C++ sliding window? My sliding window is so complicated, holy. Okay, what do they do here? I is equal to 1. What is A and what is B? Oh, okay, I imagine that's left, right, maybe? Okay. If nums I is less than or equal to nums I minus 1, okay, if it's greater than the previous, oh, Gabriel says, I think better to do 3350 adjacent increasing subarrays, detection 2. That way we can understand the efficient solution. That is true. First, let me try to understand this sliding window problem, though. I mean, this sliding window solution. How did they get it so efficient? If I minus A is greater than or equal to K, okay, and B is equal to A, okay, A is equal to I minus K. I don't understand what they're doing here. You know what? You're right. We might need to go to the next problem. No. This was the previous one we looked at. What? Is there a solution for the next one? Here. Adjacent increasing subarrays, detection 2. Is there a walkthrough for this one? There's no editorial for this too. One pass, oh, one space. Split A into multiple mono increasing subarray. Subarray as long as possible. Pre-max up the length of the previous increasing subarray. Up the length of the current increasing subarray. We can directly use 2 adjacent increasing subarray. Okay. Other option, we can split 1 long subarray into 2 adjacent halves. Oh my goodness. pre-max up the length of the previous increasing subarray. Okay, so the previous max, they use up for ascending, right? The previous max ascending, okay. The current ascending, okay. One option is k is equal to the minimum of my current increasing subarray and the previous increasing subarray. Okay, the other option is k is equal to my current increasing subarray divided by 2. Okay, makes sense. Okay, so A is the given list. My current increasing subarray is 1. My previous increasing subarray is 0. What is res? Does he mention res anywhere? No, he does not. They're doing this thing again. Okay. Okay. So starting from 0 to the end, if the current element is greater than the previous element, then your current increasing subarray plus plus, else if that means it's decreasing, right? Then the previous increasing subarray is now set to my current one, and you reset your up one. Okay, and then result. Oh, this is a boolean, isn't it? Is this a boolean? Result is equal to math.max. Oh, okay. The res. Oh, the result. Oh, res is result. Okay. Math.max of your current best result plus math.max up divided by 2. Okay, this is the case where we're splitting your current increasing subarray by 2, right? And if it's equal to k, like in this case, that means you have a solution. Else math.min, else the minimum of your previous ascending subarray and your current ascending subarray has to be equal to k. Yeah. Okay, and then you take the max of these. And for our case, I guess we just have to make sure that res is greater than or equal to k. Yeah, okay. I think I understand the solution. Oh man. This is actually kind of not that complicated once you actually get to know it. Okay. 3349. 3349. I'm going to record this down for review. Should I just call the stream here today? We literally spent an hour and 30 minutes on one easy question. Hey, petition to make this a medium question. I don't like this label. I was deceived. Yeah, sorry. My brain is kind of fried right now. To solve this easy question, we spent like an hour on it. And then to actually get the optimal solution, we had to look at the medium version. This is pretty crazy. Yeah, sorry guys. I think I'm done for today. My brain fried. We'll probably do detection number 2 tomorrow. And we'll review it. Yeah. We'll review it, but we'll review detection 1 tomorrow, along with detection 2. Dario says, do you have premium for Leetcode? Kind of. This is my brother's account actually. I don't know if you noticed, but I keep switching back and forth between Microsoft Edge and Google Chrome. This is Microsoft Edge right now. This is Google Chrome. Here. Well, yeah, here. This is Google Chrome, and this is Microsoft Edge. Chrome, Edge. My brother's account is on Microsoft Edge because he has premium, and he lets me use his premium account. But I still do most of the problems on my account, which is logged onto Google Chrome, so that it can actually mark if I did it or not. Do I recommend premium? The only reason I use premium is to get the list of questions from specific companies. That's basically what I use it for. Oh, and also some of the editorials are good too. I think it's, for me, premium's only value is the list of questions from specific companies. Otherwise, the editorial isn't like something you have to have. You can always look at the comments or the solutions of other people. But I think the editorials do make it faster to understand solutions. So it's not the end of the world if you don't have the editorial. It's just slower, I guess, to look at the comments sometimes. So yeah, if you want to save time looking up solutions sometimes, and if you want access to specific company questions like Google, like I'm doing right now, then I think it's kind of worth it. Yeah, it's definitely a time saver a little bit. Hope that helps. Okay, my brain super fried right now. 1 hour and 30 minutes on one easy question. That is ridiculous. Should I make other people do this problem too? For one battle or something? I think that would be really funny. Okay, I'm done here. I'm hopping off. Oh, also, I have a coding battle on Thursday. I'm doing a Leetcode battle against Nirino, who is a real NASDAQ data analyst. So it's 9 a.m. on Thursday, PST time. Please look forward to it, I guess. Bye, guys.
Are empty. I think this is good here, right?